This video focuses on the chemical levels of organization. We'll explore the fundamental concepts and language of chemistry, including how matter is structured and how chemical bonds are formed. You may recall from your previous classes that chemistry is the study of the composition of chemicals. Before we study cells, it is critical to have a basic understanding of chemistry because cells are made of various chemicals. There are a few new terms that I would like to introduce you to. The first is matter. Matter refers to anything that has some type of mass or weight and occupies some amount of space. Next is element. An element is going to be the simplest form of matter. Elements have unique chemical properties. There are more than 110 elements in nature, but our body requires about 20 elements. The most abundant elements in our body are oxygen, carbon, hydrogen, and nitrogen. While an element is commonly defined as the simplest form of matter, it's important to recognize that even an element is composed of smaller units, known as atoms. An atom consists of three primary particles: protons, neutrons, and electrons. Protons carry a positive charge and reside within the nucleus of an atom, while neutrons are electrically neutral particles also located in the nucleus. Electrons, on the other hand, are negatively charged particles that orbit around the nucleus. The key to an atom's stability lies in its electrical balance. Normally, an atom has the same number of protons as electrons, making it electrically neutral. However, if an atom gains or loses electrons, this balance is disrupted. An atom that gains or loses an electron is called ion. When an atom gains electrons, it becomes negatively charged and is called an anion. Conversely, an atom that loses electrons and becomes positively charged is called a cation. The atomic number of an atom represents the number of protons in its nucleus. For example, hydrogen has 1 proton, so the atomic number of hydrogen is 1, and oxygen has 8 protons, so the atomic number of oxygen is 8. On the other hand, the atomic weight of an atom is nearly equal to the number of protons plus the number of neutrons in its nucleus. Electron mass is very small compared to the mass of a proton or neutron, so it is not included in the calculation of the atomic number and mass number. The electrons of an atom are arranged in orbits surrounding the central nucleus. Each shell has a characteristic capacity for electrons. For instance, the first shell closest to the nucleus can hold up to 2 electrons, while the second shell can hold up to 8 electrons. And similarly, the third shell can also hold up to 8 electrons. Atoms of elements whose outermost shells are filled are referred to as stable and chemically inert. However, atoms whose outermost shells are not filled participate in chemical bonds to achieve a filled outermost shell. Chemical bonds are the attractive forces that hold atoms together to form molecules. When atoms combine, they create new substances with unique properties. These bonds involve the sharing, gaining, or losing of electrons between atoms. There are 3 common types of chemical bonds. Ionic bonds. Ionic bonds form when one atom transfers electrons to another atom. This results in the formation of ions, which are charged particles. One atom becomes positively charged by losing electrons, while the other becomes negatively charged by gaining electrons. These opposite charges attract each other, forming a strong bond. An example of an ionic compound is table salt, also called sodium chloride, where sodium donates an electron to chlorine to form sodium chloride. Covalent bonds. Covalent bonds occur when atoms share electrons to achieve a full outer electron shell. This sharing creates a stable bond between the atoms. Covalent bonds are typically stronger than ionic bonds. Examples of covalent compounds include water, where oxygen and hydrogen atoms share electrons to form water molecules. Hydrogen bonds. Hydrogen bonds are weaker than ionic and covalent bonds but are still important in biological systems. They form between a hydrogen atom in one molecule to an atom in another molecule. For example, hydrogen bonds help hold together the strands of DNA and stabilize the structure of proteins.